So in this video, I'm going to show you some strategies for division of polynomials. I'm going to break it apart into dividing by a monomial and then dividing by a binomial, and then I'll also show you a little trick for synthetic division. Okay, so when you divide by a monomial, so remember one term, what we're going to do is we're going to split this fraction apart into one fraction for each term in the numerator, and they're each going to have that same denominator. Now, it might not feel like that's legal, but once you see it, so each term in the numerator gets that same denominator, and I'll just keep those signs and I'll drop them down. So 24x cubed over 3x, and then my next one is going to be minus, and then I'll have 6x squared over 3x. And then plus, and then my last one is 18x over 3x. So it feels kind of odd to split it apart like that, but just think, right, we could go backwards. If we had to add these three, since they all have the same denominator, we would just combine the numerators and get right back there. Okay, but we're not going to do that. We wanted to split it apart because now we're going to just simplify each of these fractions. And right, that's how you do it. So let's see, simplifying the fractions, we just simplify the coefficients, so 8, and then dividing like bases, we subtract the exponents. So 8x squared minus, these guys cancel and I get a 2, so minus 2x, and then the 3 goes into there and leaves behind a 6, and then the x's completely cancel, so it's just plus 6. Okay, let's try the next one. If you would like to pause and try it on your own, that would be great. Otherwise, I will go along with you. So monomial, everybody in the top, right, gets its own fraction, and they all have that same denominator. Here we go. Okay, and then we reduce. So 100 over 25 is a 4. A to the 4th divided by a squared is a squared. Minus 25 goes into 50 twice. A cubed over a squared is a to the 1st. And then 25a squared over 25a squared. So these guys are exactly the same thing. So when they cancel, be careful here. It does leave behind a plus 1. So for every term that I had in the numerator of where I started, I need that many terms in my final answer. Okay, now if you have to divide by a binomial, the way we do it is we write it like I have my second one written there. So I'm going to go ahead and do that here. So x minus 2 is dividing into 6x cubed minus 4x squared minus 10x minus 3. So what we want to do is we want to look at the biggest term out in front, right, for our divisor, and figure out what I need to multiply it by to get exactly the largest term left in the underneath part into my dividend. So x times what to get exactly 6x cubed? So the answer is 6x squared. So I write that up top. Now, unlike with long division of numbers, it doesn't matter where you put it because right, we'll get everybody organized at the end. So 6x squared, but that 6x squared now has to multiply both of the terms that are out in front. So 6x squared times x. So now it does matter. I'm going to line these guys up. That 6x cubed goes underneath the other 6x cubed. And 6x squared times negative 2 is negative 12x squared, and I'm going to put that under the other x squared term. Okay, so remember when you do long division, right, after you multiply, the next thing you did was subtract. So now I'm going to subtract, I'm going to use a different color so hopefully you can see it, each of those terms. So what it does is we change the signs of both of the terms, and then we add things together. So your largest things should always add away. That was the whole idea. That's why we chose the 6x squared. So we could kind of like, we're going to chip away at these terms underneath the division symbol. So now I have negative 4x squared plus 12x squared. So when I combine those, I get positive 8x squared. And we go again. So the biggest thing out front, which is always going to be x for us. So x times what to get exactly 8x squared, which is now the largest exponent that we have left underneath. x times what to get 8x squared? So that's plus 8x. Once you have your next partial quotient up top, you take that part of it, that 8x, and you multiply both pieces out in front. So I'm going to get 8x squared. It should always match up. And then 8x times negative 2 is minus 16x. So I just multiplied it by both pieces. So now again, I'm going to get my pencil here. So I'm going to change both of those signs because it's a subtracting part. But it's hard to subtract when it's a binomial. So instead, we change our signs and we add. So the 8x squares, a positive and a negative, those go away. Again, that was the intention. And now this 16x, it's going to go up and it's going to combine with that negative 10x that we had. So negative 10x plus 16x is plus 6x. Okay, last time. So x times what to get exactly 6x? So that's plus 6. And then we multiply it. So we'll get the 6x like we wanted. And 6 times negative 2 is negative 12. And now the subtracting or changing the signs and adding. Those guys add away. And I have negative 3 plus 12 is 9. Now, I don't have any more x's left down here. No more x's up there. I've gone through all my terms. So this is my remainder. So the way we write our remainder is plus 9 over x minus 2. Okay, so this one's already set up for us. So x times what to get exactly 4x squared? So 4x. And then that 4x is going to multiply the x plus the 3, both parts. So I'm going to get 4x squared plus 12x. So I've multiplied. Now we subtract. So change the signs and add them together. X squares go away like they're supposed to. And then I have 3x plus a negative 12x. So that's minus 9x. X times what to get negative 9x? So that's minus 9. And then that minus 9 has to multiply the x plus 3. So I'm going to get negative 9x minus 27. So I've multiplied. So now we're going to change our signs and add things together. So my x's go away like they're supposed to. And I have this plus 27, but I can look back up here, right? And I still had that minus 7 here. So negative 7 plus 27 is plus 20. I'm out of x's, so that is my remainder. So plus 20 over x plus 3. Okay, so just real quickly here, I wanted to show you synthetic division. It only works sometimes. It only works if the divisor, the thing you're dividing by, divisor, it has to have this very special form, x plus or minus a number. So the biggest part here is this x. It has to have a coefficient of 1 and a power of 1. Okay, so what do we have? Oh, those last two ones we have, they both fit this criteria. So in the first one, right, the divisor is x minus 2. So here's my x. It's got a 1 coefficient, a 1 exponent, so that totally works. So here's how we do that. So I'll go ahead and write it out longhand again. 6x cubed minus 4 minus 10x minus 3. The way it works is we're going to write our division symbol upside down. We're going to take that constant term from our divisor and change its sign. So it was x minus 2, so I'm going to write a plus 2. Kind of taking care of that subtraction part right now. And now underneath here, I'm going to write the coefficients of the dividend. So I'm not going to write the x's at all. I'm just going to do the 6 and a minus 4. And I'm kind of writing it on the second line. I did my division symbol extra big, and I'm going to write it on the top line. So 6, negative 4, negative 10, negative 3. Okay, so that's the setup. And now here we go. The 6 drops down. First number drops down. And then it's a multiply. So we take the 2 and we multiply the 6 to get 12. And that goes up and over. And then we add going down. Negative 4 plus 12 is 8. And we do it again. 2 times 8 is 16. It goes up and over. And then we add going down. Negative 10 plus 16 is 6. And we go again. 2 times 6 is 12. Up and over. And we add going down. Negative 3 plus 12 is 9. Now, we're kind of done. But we know what the answer is, right? We did it already. So can you see what these numbers down here represent? Right, they're the coefficients of the quotient. So we started with a 6x cubed. So we divide by x to the first. So this first number in our answer is an x squared coefficient. So 6x squared plus 8x plus 6, and then we get to that remainder, plus 9 over x minus 2. Now, is it faster than long division? You know, once you get used to it, it really is. Do you have to be able to do it? No, not at all. Here, let me just show you real quick. When I take that negative 3, so x plus 3, I'm doing that second one that we did. I'll do it synthetically and show you how quick it can be. So it was x plus 3. I changed the sign. I write in the coefficients. First number always drops. And then it's multiply and add. And multiply and add. And then if you can go, you can start from the right as well. So this is remainder constant x. They go in increasing powers. So 4x minus 9 plus 20 over x plus 3. There is one other, so we have our caveat that it only works for a very specific type of divisor. And the other thing is, if your dividend is missing a power of x, if it skips over, for instance, if it goes from the x squared term to the constant term, it skips over the x term, you need to put in a placeholder of 0. So real quick. So I can show you x cubed minus 1 divided by x minus 1. Okay, so make sure I'm still on the screen here. Okay, so flip her upside down. So we have out in front, it's going to be positive 1. Inside here, I'm going to have 1x cubed, 0x squares, 0x to the first, minus 1 for my constant term. Okay, so I had to have placeholders for both the x squared and the x because they were missing in my dividend. Okay, here we go. First number always drops. And then it's multiply. 1 times 1 is 1. And we add. And we multiply, and it goes up and over. And we add. And we multiply. Up and over. And we add. Oh, remainder of 0. That means it went in evenly. Okay, cool. So then this is my remainder, my constant, my x, and my x squared. So those are the coefficients. So my answer, when I do that division, is x squared plus x, right? 1x squared plus 1x plus 1. No remainder.